So in the last video, I talked about magnetic fields and how they are so cool that a bar magnet like this can send out this field which does cool things. Like for example, I'm still going to show this off, but yeah, see how this is happening? It's because of a magnetic field. Now, magnetic field, and that was with bar magnets. But another very interesting thing is if we have electricity. Electricity can cause magnetic fields. And that's what we'll be talking about today. And in general, this is called the right-hand rule. Right-hand rule? Right-hand rule. So first I'll show you what I mean. If we have a current going this way, it creates a magnetic field going around it. Okay? And now, it's difficult to remember what the direction is. But if you just use your hand, it's very easy. Now remember, you always use your right hand, because in exams, you sit there and you see how people raise their left hands, and you think, oh no, oh no. But if you can remember to use your right hand, everything gets much easier. So, first we do is we just put our thumb in the direction of the current, and then we put our fingers go in the direction of the magnetic field. Okay, remember, magnetic field is north to south, like up there. So that means all these circles, the magnetic field will be going over the wire at the top and under the wire at the bottom, just following my fingers. So it'll be going like this. Okay, so that's pretty handy to know. Now that we know this, we can kind of figure out what direction fields would look like. So if I drew this, have a try with me. Try and figure out which direction the field is going. So we get our hand. I have to give you a direction of the current. And remember, this is conventional current. So that's generally just the normal current. So the current's going this way. Electricity is going to go around this direction. That's how the right-hand rule works. So it's going to be going like that. And then behind over here. Okay? Now, if we bend this wire into interesting shapes, like in the background you can see over there. Oh wait, let's try a few other ones first. So we have across, up. Let's go into the page and out of the page. Okay? So, into the page looks like this, because it's like an arrow. Imagine like an arrow, and you're shooting it, and it's like that. It's like a person. So into the page, we're seeing the back end of the arrow. Coming towards us, we see that. Okay, so that's generally what they mean. Into page, out. So what will the fields look like for here? So into the page, our hands curl around this way. So the field would be going around this direction. Out of the page, our hand curls around this way. So it'll be going that direction. Okay, remember, always use your right hand. Even though you write with your right hand, it's very tempting to use your left hand. You can try and use your left hand and know it's reversed. So if I'm using my left hand and then I need to reverse it, but that's very confusing. Just use your right hand. Okay. So now that we know all these, I'm just going to do a few other basic ones. If we do a little loop, so imagine my thumb going around the, I need to give you the direction of the current. My thumb going around the loop. No matter where my thumb, no matter where along the loop is, my thumb is going, the field is always coming towards us. So we know that the field is coming towards us. Just so you know, this is how we draw. This is how we draw fields, not current, I think. Yeah, so the field is always coming towards us. And on the outside, if you imagine it, I'm going to put my thumb on the outside. The field is always going away from us. It's interesting. So, because my fingers are going away, you see that? So that means it's always going into the page. And this field is usually much stronger than the outside field, and I'll tell you why. Because if we just had a wire, and we had that much, the fields are equal on both sides, so there's that much field going in and that much field going out. But now we've taken all of this area and we've wrapped it up into a small part. And all of this has become this huge area out here. That's why this is usually so much stronger than that outside, because these things were equal at the start if you made it straight, but then you bent it into a circle, and becomes much stronger than the ones outside. So they may ask you for density questions somewhere along the line. But anyway, enough talking. Let's get you doing some questions, and I'll start with question 1 next.